Good morning and good afternoon, everybody. Thank you guys for joining today. Today, we're going to be covering mastering main and sub machining with dual turrets and ESPRIT EDGE. We're going to have questions at the end. If you feel free to type in any questions you have throughout the whole webinar in the chat box, and we can get to them at the end. We'll talk about programming a part, adding a part in, setting up stock, setting up on the workpiece inside the fixturing in ESPRIT EDGE, and then programming a part and converting it over into production machining in ESPRIT EDGE. All right, let's get started. All right, so the first thing you always want to do is have your file set up to save time. I already have a machine set up with tools on the lower turret and tools in the upper turret setup. This Akuma machine is a Multis U3000 with a lower turret without Y and an upper B-axis 5-axis turret with 2 spindles. Next, we'll go to our part side. I always like to have a layer called part setup. From there, I'll go to File, Import, and I'll import in the part I'm going to use for this. So I want to check import as new part. That will add the part as a part in the part setup for Edge. I'll run CAD diagnostics and it doesn't find any issues. If I needed to, I could shift where the origin is on the part, but I like where the origin is on the nose right here. So we'll be good there. I'll go to part setup, make sure I have my part. It's already in there. Then I can add a bar. It'll automatically size the bar for the part. And then I can just increase it to whatever bar I plan to program with and set my inside diameter and outside diameter. From here, I'll set my align top for Z, so it's going to align to the face of the part, and I'll set it to a 10-inch bar with 50 thou on the face. From there, I've got my stock and part, creating a workpiece in ESPRIT. So I'll go to machine setup. And now that I've defined my bar as 3-inch, let's put some 3-inch jaws on my collet here. So I have a Royal collet with QG80. So I'll go to my QG80 and I'll put 3-inch collet in. And I'll click OK. Then I'll select my fixture and I'll click workpiece. From here, my part should snap to the front of my collet, so then I can decide how far out I want it. For right now, I'll just put it out 5 inches and click OK and OK. From there, you can see I can adjust the visibility of my stock, the transparency of my stock, allowing me to see the part inside my workpiece. So if I turn off transparency, you can't see the part, or I can adjust it. So we'll go back over to part setup, and from there, we should be good to start programming with features and operations. So I'll go to my layers up here in the part side, and I'll click plus. I'm going to make a layer called features. And I'll also make a layer called operations. And I'll make sure features is active by double clicking it. Whatever is in bold is the active layer that you are currently drawing on. Please note that you can draw or add things to a layer that are not visible. So if you have the check mark off, you can be drawing or adding things to a layer and creating things on a layer that you can't see, right? So be mindful of that. So we're going to have it visible and active. From here, I always like to make my turning features first. So I'll just select my whole part. I'll come up here to turning. And I'll select the center line axis. From here, I can make adjustments for how my features are going to get created for my turning operations. You can check out your machine zones down here. Cool thing is I can adjust the beginning and end point for my main or my sub turning, right? So right now my front OD start location is right here at the tip, which is great. And my OD end location is right there. If I did not want to turn this big section right here, this OD in the main, I could always right click OD end location, select digitize new position, and then define a new position. And that would make my back OD on that section instead of my front OD. So we'll put that back to where it was for right now because I want to turn that whole thing. Right. You can also control whether you're going to get OD, ID, or face toolpath or features, whether you're going to program in just the main or the main and sub or just the sub. There's a lot of options in here for grooving on whether you want the profiles, the contours to skip over the grooves or whether you want them to go in there. We don't have any grooves in this part, so it's not going to affect us here. You can also see previews. So if you go to the features manager, you can see previews of the toolpaths that you're going to get or the features you're going to get, right? So I can see my front ID, my back ID, my back face, and my back ID groove. Oh, that does count as a groove. All right. So let's go to front ID, just appear at that, make sure I got a good start point. All right, so then I can go back to turning and click OK. All right, from here, I can quickly find all the holes in my part by going to the feature ribbon again, selecting my whole part and go to hole. Hole is going to search for all the holes in your part based on the parameters you've defined here. I usually leave a really large max diameter to find all the holes and a really small, usually 0 minimum diameter to find all the holes between 0 and 4 inches. Minimum hole opening angle is going to define how much of a hole needs to be present for it to be found as a hole. Meaning if I put this at 90 or less, it would find corners of these rectangles right here, the round corners of these rectangles as holes to drill. So 270 is a good spot. Sometimes I'll put it lower depending on my needs. Combined coaxial hole will turn these two holes into one hole from each side. I'm going to turn that off. I want 2 separate holes that don't go all the way through. Propagate hole faces, yes. I want to find all the details for the hole. Active work plane only, no. I want it to find all holes, not just holes that can be done on my current work plane. Split custom holes, I'll select yes here because this right here is a custom hole and I just want to drill through the middle. So I'll click, let's see, I'll click OK, and I should find that counter bore, that counter bore, this custom hole right here, those holes, this hole is separate because it had a different depth because of that radius. One custom hole right in the front. There we go. All right, from there, I can create some milling features like profile and pockets on the back. We can always wait to do those towards the end as well. So we're going to do those once the part gets moved into the sub. We have enough right now to work our main all the way up to the transfer. All right. So again, parts set up in our machine. We have some turning and hole features. So I'm just going to activate my operations layer. And now we can start programming operations. So let's go to front OD contour right here. And we'll go to turning. And we're going to do a roughing operation. So I'll system default all when it opens up. Operation name will be rough the OD and the main. Right? You can name it wherever you want. I just like the name. So main, rough, face, and OD, that's the tool I want to use. Put some speeds and feeds in here. Let's see. Update stock, yes. We'll go to strategy. This is going to define how I want to complete the task. I don't want to finish pass. I have a separate tool I'm going to use for finishing. If you're using the same tool for finishing, you can add a finish pass here. Undercutting mode, there's not an undercut to worry about, so I'm going to leave that alone. I don't need any undercutting. If you wanted can cycles or cutter comp NC, you could output that right here. I'm going to go to rough. I'm going to leave 10 thou on my Z and X. I can change my rough patterns if I wanted. I'm going to do parallel to axis, and I'll set that I'm going to do 125 thou per pass. Sorry for the double decimal. My lead in and out for this front, because it's actually, if I did tangent, it would just go straight in. So I'm going to do normal tangent so I can come normal on. and then machine to that. So let's say normal tangent. Let's see, let's just do tangent for right now because we're in the rough pass. And lead out, I will do normal of 50 thou as well. So both of those 50. Links. I always like to set my links to a specific location. I'm using a 3-inch bar here, and I like to leave I'll come in with the tool. I'm going to come in X, then Z. So X, then Z, and I'll set my Z point at 1/2 inch in front of the part. And then I'll set my X at 1.625, right? So this is the radial value because it's working from the origin. So this will end up being larger than 3-inch. And then my exit move, I will do Z, then X. Well, actually X, then Z, sorry. I'll do 0.5 and 1.625. I just like to see when I'm running the machine in real life that the tool is going to go to the same location after each operation, so I can see if my tool offsets are wrong on that particular tool. It's a good setup technique, and as you can always bring those in as you've confirmed those tools. You can bring them to start and end closer using those link positions. So you could change this to 200 thou or 100 thou, and you could change this to 1.55, 1 inch, 550 thousandths. Right? So there we go. If I watch this operation in simulation, I should see my tool starting from right there, right? Because I'm started the operation, I'm not showing the whole tool change right here. And then I'll set it to go. You see it moved in X, then Z, and it's roughing the part. I can speed up just a hair. All right, so I left some material on this part. One thing I do want to note is I probably would like to extend the end of my operation so that my cutoff tool has a nice turn section to hit when I'm programming. So I'll do an end extension. I'm using a 3mm 118 thou cutoff tool, and I plan to leave 50 thou on the back. So I'll extend this to 170 thou. So it's 118 plus 50 thou plus 2 thou for good measure. All right. So I'll hit OK, and you'll see that extension right there. So now I have a nice turn section for my cutoff tool to engage. All right, next, I want to drill this big hole in the front. So I can come up here and find custom hole. I'll go to milling. You can use turning or milling because it is in a spindle and it is on center. And I'm going to also use the B-axis head, right? So from here, I can say milling, and I can do drilling or turning and drilling. You're going to get the same options inside both. So I'm going to system default. I'm going to say on center big drill, and I'll drill with the 750 thou drill. It's going to show you a preview of the orientation and the holder. I'm going to put in here 5,000 RPMs, and then I'll put 10 thou per rev. So here's where I can adjust it. First, I want to use previous stock for starting depth, yes. And then machining strategy, I can do tool spinning, part spinning, or tool and part spinning. So if I do tool and part spinning, I get the option to mix and match the spindle RPM with the tool RPM. So I'll put the tool RPM at 3,500, and that leaves the spindle RPM at 1,500. I'm going to do a through depth of 1/2 inch to go a little bit further, and that should be good. First thing I notice is I get an alarm over here, so let's look at what's going on so we can watch. This is something you're going to run into anytime you're using 2 turrets and edge. That, right? 2 things, I could park a different position on this turret. I could park a different spot, or I could park the turret between tool changes at a different location. So let's do that. I'm going to right click. First, I need to leave simulation. I'm going to right click this tool and go to edit tool change, and I'll set position of 0 for right now. And that should correct that. So now when you watch simulation, this tool change will happen right here below the part. You can do that for every tool change in here manually, or you can set the whole machine up to do that regularly. So now it'll stop right there and you'll have plenty of room to do your machining. All right, so let's continue on. I will do let's do the bore on the inside. So I'll do front ID contour. I'm going to go to turning and I'll go to contouring. And I'll go to system default. I'm going to say finish ID. I'll turn this main ID turn 3,000 RPMs and 3,000 per rev, just putting some numbers in there. I don't need a start or an end extension for my lead in. I want to do normal tangent of 50,000 each. And you guys can do whatever you prefer here. That's just my preference. Same thing for my lead out. Now, ID work is somewhere where your lead in and out is really critical, or your links, your entry and exit mode are really critical. So we're going to do a X then Z for my start, and my Z point will be 0.5 again, and this will be 1.625. This is going to come along X and then move in through Z. And my exit mode, I want Z then X to get out in front of the part and then move away safely. All right, and I'm going to get another issue because I need to change the tool change here to position. So there we go. So now we can see that. All right, let's get to programming some more. We'll finish the OD. So I'll go to front OD contour. And I'll go to turning, and I'm going to go to contouring now. So general, default all, I'll say finish OD, choose my main finish face tool, face and OD tool, and I'll say 4200, 3, strategy. One thing you're going to notice is that is the wrong orientation because I chose sub finish, right? So you can, the preview is going to show you that's the wrong orientation for the tool. So let's switch it to main finish. Gotta love the preview there. It helps you out a lot, especially if you choose too quickly like I just did. All right, so start an end extension. I don't need an end extension here because I want the rough turn to be what my cutoff tool engages. And contour, I'll do a normal tangent lead in of 50 thou for both, and a lead out normal of 50 thou. Same, I will do X then Z, 0.5, 1.625. Exit mode will be X then Z as well. Right. So we'll watch that one in a second. Let's get to milling these two round spirals so that my drill for these two locations has a nice flat spot to engage with. Right. One thing you'll note, and I said in the beginning, is this tool, this turret on the lower does not have Y-axis. So we'll need to do the spiraling up here. If we didn't have a tool the exact size, we'll need to do the spiraling with the B-axis, and then we can drill it with the lower turret. So let's find those two holes. We've got that one and that one, and we'll go to milling, spiraling, and we'll use an end mill to spiral those. All right, so system default, I'll say spiral nose holes, and then we'll use the end mill, 1/4 inch end mill, and I'll say set some speeds and feeds. Incremental depth, I'll set at 40 thou. I want just a clean spiral down, so we'll just leave that. This is a good way to get a flat so that our tool, our drill can engage on it. All right, and I want my start point to be positioned center of hole for both lead in and lead out. And I should get something like that for both. All right, now I can take both of those or select this feature set that I just created by selecting both of these. I created a feature set, and so this is a parent op that covers both of these ops. Now I can select this feature set and I can do a drilling operation as well using the lower turret to drill those holes. So I'll go to general, system default, and I'll say drill nose holes. And I can look at per turret down here. Let's see. Turret 2, station 7 has a drill. So if you don't know where you put that drill or the name of it, I can look at these by station and say, okay, the only drill I have on my lower turret is this drill. That must be the drill, right? And if you don't see it there, then you need to make the drill and set it up. So we'll set the speeds and feeds, and I'll use previous stock for starting depth. Hole through depth, let's just go through an extra 125 thou, just so we break through the center. And I'll click OK. Now I should get an alarm here. Oh, it looks like it cleared, but let's watch. I'm just going to watch. We haven't watched from here or down, so we'll watch there. Very cool. I've got my half split on. That's why the finish looked funky. So I just rough or spiraled those. And now I can drill those. All right. I may need to change this drill tool change later on. We can change it now. So let's just right click and I'll say position 0. All right. I wanted everything changing right underneath this main for right now. And then if we need to adjust it later, we can do that. All right. So we're at a good place now to grab with our sub, pull the part out, do a cutoff, transfer, and then start working in the main or start working in the sub, right? So the first thing we need to do is go to turning, and we're going to do a pickup. As soon as I look, I notice I don't have collet chucks on or collet jaws on here yet because I didn't know what part I was grabbing, right? I like to build this as I go. So I'll go cancel, I'll go home and set up machine setup. I needed to figure out what collets I want to use. So I can go to my part and select whatever I'm grabbing onto and go to the solids tab over here. If you don't have that on, you can always go to show hide on the home ribbon and find it right here. And I can find the diameter and radius. So I've got a 1.181 1 inch, 181 thou diameter right here. That's not a concern. What I'll do is I'll go to machine setup. I'll select my chuck on the sub side. I need to add jaws, and it's got QG collets, QG80 collets as well. So I'll choose 1.125. Let's see. Nope, we'll need to go bigger. Let's go right there. So now I've got some collet jaws on there that open and close as well. So now I can come over to the part, turning ribbon, pickup, and I can program my part. One thing, as soon as I start programming with my sub, a couple things I want to make sure I did previously. I'm going to program my pickup, and then I'll show you what we need to make sure we did. I'm going to system default. I'm going to say pickup. I want to use the sub one, which is 416166. Right, and it shows you a preview, which is awesome. And then I want to grab on -1 inch onto my part. And that should be good for now. Spindle feed rate, let's do 50. Sync oriented is fine. So there we go. All right. So remember, anytime you're programming with your sub, you want to make sure that you set up where your B0 is set on your sub. To do that, we're going to go to our work offset. First thing I notice, this is an Akuma. I haven't set up the work offset yet correctly. G54 would work on most machines. Let's double click G54. For Akuma, we're going to switch this to custom, and we can call it 140 here, and primary number 140. Name is just it's just a name, doesn't matter. Primary number is the output we're going to get for the machine. Next, we need to set our ZS2. So we'll click this digitize. This is setting your B-axis 0 position. We'll click the digitize arrow here. We're going to choose the front face of our part. And then we're going to choose the front face of the collet here. And it's going to snap that nose to that front face. And we're going to say, that's it. That's what we wanted. Now we've set the B position. So when we output code, Esprit knows where your B is and how to give it code. If you don't set that, what's going to happen is your B values are going to look way off, right? Because you're going to get large B values, assuming that you are leaving the B0 way over there where the subspindle is at home. So that's just setting your B position just like you would do it on a machine for your work offset. So we'll click OK there. And now we're ready, right? Let's go to simulation, and I'll just simulate towards the end here so we can see the pickup. And we might need to park this lower turret if we start getting collisions. Let's see. Yep, this turret's in the way, so we'll have to park it out of the way here in a second. For right now, let's just run it through. There it is. So it picked up successfully. To show you how to do a park, we're going to go to turning, and we're going to go to park. And I'm going to say park lower for pickup. Tool change, I'll select tool, and I will do my cutoff tool. Park position is going to be position. Let's do -5 inches so that it's a little bit behind the part. All right. And X, we'll do home. Y is going to be none. We don't have any Y in here. We'll hit OK. All right. First thing we want to do is we're getting an error, probably a collision. Yep. First, let's set our tool change position here. We're going to do position, and we'll do -5 on this one. Then we need to reorganize, right? First, this park in the operation list. So in Edge, you have an operation list and you have a program list. Operation list is for your whole part. Program is for your whole machine. So the right side is for the machine. Left side is for how you're programming. I will not be able to move this park above the pickup, right? I can move it next to, but I can't move it above because it is not above before in the operation list. So I'll go to park lower and I can drag it up above pickup. And now it's going to happen before my pickup. Right? There's other ways we could have done this. This is just a really safe way, right? So now I can confirm and run this. And now I know for sure that this subspindle has room to come over. There you go. Again, I could have done this many other ways. I could have actually programmed my cutoff operation and then dragged the tool change and link above the pickup operation in the program side, right? So I'll show you guys that as well. For right now, we need to do a bar pull. Let's find out how long our part is. We'll select the whole body. We're going to go to the solids tab, and we're going to get the Z length of 3.228346. Next, I'll go to turning bar feed. I'll go to operation is bar pull, and I want it with bar pull type. I'm going to do it with my subspindle. Feed rate 10, feed length. This is going to be equal to 50 thou I left on the front, plus the part length, which is 3.2. I'll have to get that number again. Thought I was going to copy and paste it for me. Plus the 50 thou I'm going to leave on the back, plus the 118 thou for my cutoff tool. So let's copy that, edit properties, and I'm going to put it right up. There's the number. So I'll go equals 50 thou plus that length plus 118 for my cutoff plus 50 thou. So there's my feed length. And if I ever need to change something on it, I can right click and come in here and adjust the expression, right? So it's going to save that expression for you. So you always can come in here and say, oh, I left a different amount on my subs or my backside. I need to adjust it. You don't have to recalculate it. You just come in here and you adjust this. All right, and you can automate some of that as well. But for right now, we're just doing it the quick and dirty way. So now we should get a bar pull. Now we should also get a reposition. So if we double click this, you can see the preview and the reposition based on where your work offset was. All right. So next we need to do our cutoff. So we'll come back to the part side, features manager, and we're going to find our back face right here. And I'll do cutoff operation. So system default all, cutoff. I'll use my cutoff tool. I'll put some speeds and feeds on it. Strategy, rough pass is fine. No part catcher. And rough stock allowance, I'm gonna leave 50 thou on the back because that's what I've calculated. I'm gonna go to a negative 30 thou just to make sure I don't have a little nib on the end. And that should be good. Links, I can always do the similar links and just come in X only in this one. And I'll set the X to like 2. And that should be it. So now I should get a transfer after the cutoff. So if I watch simulation, I should pick up, pull out, move over, cut off, and now I'm ready to start programming in my sub and continue programming in my main. All right, so moving on, we'll come over here. We can do some drilling with our B-axis head. We can do a lot of work. Most of the work on our sub side is going to be on our B-axis head. So let's continue on with that. I'm going to go back to features layer now. So I can start creating features. I can turn off the operations layer. So that way I'm not looking at my features that I don't need to see anymore. I can also create a separate features layer for sub features, right? If I want to do features I'm going to use for my sub side, that way I don't have to see these features in the way, right? Some of these features for the sub side I've already created, but some of these pocket operations and things, maybe I just want to cleanly make it here. You can always organize your layers however you see fit. So I'll just select this loop at the top right here. And I imagine I should be able to go to feature and click pocket, right? That's one of the cool ones is loop. It's automatically going to find me my work plane and find me all the details for that pocket. Now I can do the same thing down here on the other side, hit the loop on the bottom and hit pocket. And now I've got 2 pockets, one coming from each side, if in case I ever want to just meet them halfway, if this was a harder material or not makeup material like we have right here, right? So I can do similar here. I can select the loop, right, and hit pocket. And there I've got a pocket just like that, right? Which is perfect. And then for this one, I'll select loop. You could also select all the inside walls if you wanted. Loop is usually and more consistently the best option. And it also gets a lot of detail, right? So I'll hit pocket on that loop. And it found me all of that. I probably don't need all of that, right? It found me this really deep pocket, all these islands, right? And I don't need all of that. So let's delete that for right now, right? Let's say I just come in here and I find the pocket with all these faces. What I'm using is shift, and I can control how I'm propagating these faces, and control is adding to that, right? So I can propagate all the faces around. Let's see if that works. We'll go to pocket. Found me a very strange one again. Let's see. All right, that looks like the pocket. Perfect. Now it didn't go all the way to the floor, which is not a problem. I can always adjust that. I can come into my properties window right here and I can go to machining, right? There is a radius on the floor, so maybe that's what was messing it up. Let's go to depth. I'm going to use the digitized arrow and I'm going to set it to the floor. I was choosing it from the other side. Okay, that makes more sense. I'm going to come up here and go to features and click flip. That's going to flip the Z-axis direction. Then I can come up to depth and adjust it right there. Then I can also come down here and do a bottom blend type, a fillet, and then whatever that fillet size is. So I need to find out what that fillet size is. So let's go to fillet right here, set it back to none. I'll just put a value in here for right now. And then I can go to solids. Let's see. There it goes. You can adjust your start point and your lead in point. Computer is thinking. There we go. So now if I look at that pocket, I've got a fillet and a 200 thou radius. Let's confirm that radius. I can select this face and I can see the radius down here in the properties window, or I can go to solids and see the radius here at 200 thou as well. All right. For up here, I have a couple ways. I could select this face right here and go to feature and just choose pocket. And I would expect it to find me a pocket and then find me boundaries for this section so you don't violate that. Similarly, I want to face all of these outside faces to create the flats. So let's start there. I'll just select this face, or I can select just that loop and click auto chain, right? And it built me a chain with the z-axis correct. I can choose this face and choose auto chain as well. Choose loop, click auto chain. What I'm doing is left clicking and right clicking until I get the loop that I want, and then clicking auto chain, right? So loop, auto chain. So now I've got all those faces, and I can also face this back end if I wanted as well. All right, so I've got all these chains. Let's start there and face all these parts off, and then let's actually face this boundary as well. So I'm going to select all of these and go to milling and go to facing. Facing is one of my favorite operations. I think it's pretty smart and it's free. So we'll go to facing and we'll choose our face mill, and I'll choose some speeds. So we'll go to 4 and then 5 for that. Use previous stock, yes. Strategy, let's do one way for right now. Optimal finish pass, yes. Total depth, incremental depth, we'll do 100 thou. Let's do 150 thou. All right, links should be good. We're gonna hit OK. What I want to see here, not what I want to see, but what I'm going to see is a lot of probably collisions. So let's watch and see if we can see what happens and then how to fix it. Right? Okay, bang. Already hitting something. All these operations are going to crash. That's what's so cool. If I double click this facing right here and I just go to collision detection, fixture avoidance, yes. Clearance override, I don't need this. But you can adjust it if you wanted to override your default clearances or clearances you had previously set. Now, I imagine it'll fix it all for me. It's one of my favorite reasons for using facing, is now my toolpath is not colliding with my fixture, which is a good day for everybody in the machine shop. There you go. Let's see. Looks good. All right. So now I can hit stop. And let's do this boundary. I'm going to do the exact same facing op just to quickly get rid of some material. Same, everything the same. I'll just hit OK. Cool thing is how facing works is it works off the 0 point for your feature, not the depth, right? So this facing op should not go beyond the 0 point for this boundary up top. It always machines to the 0 point, not below it, right? So that's why it's really good for using on the top of pockets to quickly get rid of some material. Now for this actual pocket operation, I can use an end mill to finish up the outside. So I'll go to pocketing and I'll click system default all. General operation name will be pocket outside. Rough, let's choose half-inch end mill's fine. Let's actually go with the 1/4 inch end mill. Use previous stock, yes, it's only going to cut where it needs to. Strategy, I'll do profit milling. And I'll set this to like 10%. Cut speed. Oh, I'm also, since this is an open pocket, I highly recommend hybrid. They have a release on hybrid profit milling for open areas. It's really, really beneficial and creates a peeling effect most of the time. There's other ways other way it calculates as well, but the peeling effect is very efficient. So for slotting, let's say if we did have any slotting, I'll just put some speeds in for there. And incremental depth here. I will put 0.4. Pocket, rough, let's put some speeds and feeds in. Max speed 200. My engagement angle, I'll do 36.7. Helical contained. I don't have any really open areas here, but if I did, let's set this 120 and then this to 50 thou. Helical angle will be 5 degrees. And I'll hit OK. Right. But now I've pocketed that. All right, let's watch that operation and make sure we've got no issues up there with our V-axis head. All right. So from here, a couple things. Let's do the pockets on the middle, and I also need this radius right here we could program as well. Got some holes to drill. Nothing serious left, but let's get to work on it. All right. So for these, let's see, for these 2 holes or this set right here, we'll go to milling and we'll go to drilling. One thing I want to note is I do have 2 separate sets here. I can fix this by just double clicking this right here, and I can add a point to it, right? So let's add this other hole. So what I did there just to walk is I double clicked the feature set. I clicked the simple hole up top, and I clicked the add new hole to end of collection. And then I just clicked the center of this hole. And it looks like it oriented it incorrectly. It's interesting. It's adding based on my work plane right here. So let's fix that. There we go. There it goes. Now I can hit OK. From there, I don't need this extra one. And remember, that was created because the depth difference from having that radius there and not. So I'll just delete this feature set and just use this one. All these holes I'm going to do through depth 100 thou anyway, so it doesn't really matter. So we're going to go to milling, drilling. This one we can't do part spinning because it's not on center, right? So we'll make sure tool spinning is the only one. And we're going to use the upper head drill, and we're going to use the 157. And we should be good to go there. Through depth, the 125 should be good. And so now I've got those. I'm going to rename that to drill 4 flat holes. There we go. You can see how through they go inside, and you can always adjust that, right? Next, let's do all these pockets. 1, 2, 3, 4, right? It's gonna automatically orient for most of them. So let's say I'll grab all 4. I'm gonna do similar pocketing operations. I'm gonna go to milling, pocketing. And general, and I will choose system default. I'm gonna say pocketing in the sub. And I will choose my bullnose end mill with the 200 thou radius. Just for simplicity. Strategy, I'll use profit milling. Set that to 20. And hybrid's not going to make big differences here, but it's good to have. If we're doing slotting, let's do 25. And then we'll do 0.4. And anything else, incremental depth, we'll do let's do 0.625. Rough, speeds and feeds. Put some speeds in there. And then for this, I'll do 12%. Entry, helical contained, minimum radius 1.2, maximum radius. Let's actually put the minimum smaller, put 0.075. And the maximum we'll put at 1.75. And 5 degree helical entry, and we should be good to go. Right, so I've got that operation. One of these operations. There we go. All right, so we can watch all of these work as well. Make sure there's no issues. So we've got pocketing outside right there. Then we'll drill the 4 flat holes. We can speed it up just a hair. Like I said, I might not need both of those coming from both sides, and I can always adjust them. Right. So I have one coming from each side. So what I can do is I can just have them meet in the middle, right? So what's the total depth on this one? I'll go to strategy, total depth 1.7. So that's roughly 1.8, right? Which is 0.9. Oh, don't want to change that. Let's do 0.625 again. We'll put this total depth at 0.9. And then this one, we'll do very similar, put 0.9 for total depth. So that way they're crisscrossing in the middle. Again, you might not need to do that. You might be able to or get it from both sides, right? Let's do a between curves on this face right here. That'll be a lot of fun. What we'll do is I'll create a new layer called covering, right? And I want to put a covering on this face so that my between curves can work. So we'll go to the modeling tab and we'll go to covering. And let's see, smooth surface, attach the solid, create covering as sheet. Yes. Edges to exclude, we'll exclude that edge and these outside edges. So I just want coverings for the holes. Let's actually remove, I want those middle ones too. We'll hit OK. So now I have these sheets. So what I'm going to do is go to freeform or feature freeform. I'll choose these as check surfaces. And then I'll choose these as part surfaces. All right, so now I have a freeform freeform feature. and I'll go to the freeform ribbon, which is where the operations are going to be. Right, and I'll go to between curves finishing. Default all. And I'll do between curves. I'm going to choose a ball end mill. Let's see, I got a 0.2. That's the smallest one I got. Yep. So we'll use that one. And I'll say, 4,000 RPMs, 5,000 per rev. Update stock, yes. Toolpath. Tolerances here, instead of profiles, I'm going to use looping, and it's automatically going to loop around that. And I can do optimize scallop height, yes. Let's say I want 4,000 for scallop height. There it goes. All right. Simple enough. I should get something. So now I've created that curve using a between curves. I created that radius on the part. And again, you can always trim it or make the scallop height smaller, and it would give you a smaller step over, so a finer detail. Right. So just getting rid of that now. If I want to do this bore right here, I could come up and say, how are we doing on time? All right, so this, I could bore this, or I could choose this face or this, and go to feature, and I could say that that's a pocket, or I could just chain it, right? And I get that chain, I'll go to milling, and I can do spiraling here. And I think I can use a bigger tool. I'm probably too big. So with this spiraling, I'm going to do a step over. So let's do a 20% step over. And I want a true spiral. And that should be good. So now, because I did a step over, it's not just going to spiral down, it's going to spiral out and then step down. Okay. So big thing here is program the main, program some sub work. How do we get it so that we can see it running in the main and sub and make sure our machine's not going to have a problem running actual production parts? If I come right here, I can't go to production mode. The requirement for production mode is that you go from main to sub and you have an eject. So before we can put it in production mode and optimize the program, we need to have an eject. So let's go to turning, and we're going to go to release. Right from here, I'm a system default, and I'll go to release. We're going to say eject the part, and we're going to eject it from the sub spindle, and we're going to do a part shoot yes. And we're going to hit OK. So now I have an eject the part, and you can see the part, right? I'll show you. So let's also come up here to our transfer and make sure that we set up the work offset. Right now it's just called work offset 1. We're going to set it to 141, primary number 141, and hit OK. So that's good. So I double click the transfer and made sure my work offset for my sub side is correct, right? And you can see the preview right there. All right, so now if I watch simulation, I'm going to watch towards the end so we can see the eject, and then we'll go from there. So we're doing some machining. Let's see where we're at. There we go. And they ejected the part right there. Right, where it ejects the part's not important as long as it gets out of the way of the machining. Just imagine it's going through your part chute and leaving the machine. So now if I go to home, program mode, I should see production, right? So if I click that, ESPRIT is going to mix it all up and automatically put it into positions, right? There are going to be some errors you're going to have to solve. We'll go through and look at those. I always make sure after hitting production, I just glance and say, causes a machine collision. Let's look at what that is first, and then we'll take a peek. So, all right, that's because the tool that's set up the last tool change over here. So maybe we could put a part for this section. Maybe we have to adjust it. Let's first go to home, optimize program. There it is. So let's see. Now let's watch simulation and see if we have some things we need to fix. So now we're working on both the main and the sub at the same time. And there's always going to be optimization that you can do, and every person's going to have a little bit of different optimization. Right now, I could be doing more work on the main, right? So we can't do it until the drill happens first. So let's make sure, let's do the drill. Let's do the drill on the main before anything else. So I'll come up to the operations list, and I'm going to say, let's see, on center big drill is the first thing that happens. Then I can put my finish ID and finish OD, right? So now it's going to automatically blend those. Let's see. I want to move this finish ID up. We might not have a lot of room, but we'll see. We might have to sync it to be after something else. And let's do the finish ID up here as well. All right, so we're just optimizing the program. Now we have two syncs. We'll get rid of one of those. And let's come over here. Let's watch what we've got. And you can see how you're optimizing your program is I want to get that done, and then I can start working on the facing over here. And now I'm doing my rough OD on the main and all these facings. And you might want to create syncs, and you're also going to need to create master channels. And I just saw a tool change I don't like, but we can adjust that as well. Right, so we're parked here. I might want to park it further. So we can come over here, and this next tool change, we can actually edit this tool change position to be -5 instead, right? And then I can move that tool change separate from the operations. I can move just the tool change up and say, I want that tool change. All right, let's see. I want that tool change up here to happen. Right, so now that tool change has happened so that all this can now happen with that tool change, that tool out of the way underneath the main by another 5 inches. So let's just watch from right there, and you can see that. All right, so I expect that that tool change will move the turret further out of the way for this for the B-axis head to come in. We do need to finish that, change that main finish OD tool change as well. But see, now that's further out of the way, and the tool is called up. So cool thing about ESPRIT is I can change the links, and the tool change is separate from the operations. I can move them around in the program list with the syncs. Right? If there's any other main work we could do, I guess if we did these spiral nose holes first, we could get these drill nose holes further up as well. Right? So that's another change I can make. We're about out of time. Let's see. Like I said, another change I could make to optimize it is move the spiral nose holes right up there at the beginning. And then that way these drill nose holes could be happening on the main while the sub is working. So let's do that real quick, and then we'll go from there. I'll say I want this to happen right there. And I need this sync so that after this big drill is when all this can happen. Let's see what issue. Too close. Okay. Let's edit the tool change. Oh, okay. So it's happening. I need this sync now to happen after, and we can't do it unless we move these up in the operation list, and then it should automatically sync them for us. And let's take a peek at what issue it's showing us. Drill. All right, bam. Because we hadn't turned it yet, right? So you're going to run into this where you're optimizing too far and you're not accounting for something else, right? So I imagine you could set your your starting depth higher if you wanted, or we might just be smarter to put those back down there after, right before the drill nose, and then let it do those, right? So one thing I want to show you is how do we set master channels? We right click a tool change or a sync or just the channel. So here I want my master channel, right? For the sub spindle or for the main spindle, I can set that by clicking on that sync, and that's the master channel, all right? Because that has the turning ops. You could set master channels here, right? I can come down here and say, okay, well, this one's the master channel now, and then this one is the master channel then. We still got an issue. Let's look at that. Oh, okay. All right. One thing, let's look. There it goes. All right. Should be, let's look here. And I will rebuild. Still not letting me. There it goes. All right, that one doesn't want the master channel there. One thing we need to see, right, if we want to post out code, cool thing about a lot of ESPRIT Edge and just ESPRIT post in general, they're awesome, right? Machines centric. So if I hit NC code, it's going to tell me if there's operations that don't have their setup correct. So this one did not give me issues. Let me turn off some master channels and show you what kind of errors you get if you didn't have your master channel set. Just going to turn some off. I expect to get an alarm. Must have one set somewhere. No. A lot of times it's going to give you an alarm. It looks like it's automatically because there are no dual turning in between syncs. I did too good of a job optimizing it. So let's see. That should be it for today. Sorry I ran a couple minutes extra. Well, thank you guys for joining us on today's webinar, and we look forward to having you guys on this next one this month. We have one in, I think, two or 3 weeks at the end of February. And obviously let us know if you have any questions.